All right, we're going to start. Welcome to our meeting. For real this time. Today, I'm going to be talking about Java idioms. I gave a 4-hour lab version of this talk in person at KCDC. This is a much shorter talk because we're not going to do the labs or the breaks. So it's organized into 4 modules because I'm using the same format. So we're going to do some talking, then I'm going to show some code, and we're going to repeat that 4 times. Feel free to have lots of pizza. And then at the end, we're giving away those 3 books. One of them is mine, and 2 of them are Trisha G's. Say about me, I'm a Java champion, an author, first robotics mentor, and I've been doing Java for over 21 years. Some of the material is from my books, but I own the copyright, so that's cool. We're going to do a quick version of Java quiz. Who's using Java 8 in production? Okay. 11? 17? 7? Oh, good. Oh, I'm sorry. 6? All right, we got 7. Is anyone using a version I did not mention? Someone saw a JavaOne 2 application. Luckily, it wasn't his. All right. We're going to be talking about a mix of Java versions. And for things that are in versions newer than 8, it says what version they come from in little bubbles on the side. So you can see what's available to you now and what is a future state type thing. We're going to be talking about strings and text blocks, RegEx, collections and streams, file IO, and other random APIs I think people should know. The reason we're talking about idioms in the first place is because they help you code faster and more effectively. These are like little patterns of behavior that you use where you don't have to keep rewriting the same thing. They're not anti-patterns. Anti-patterns are things you shouldn't do. And they're not patterns either. Patterns are larger than idioms. But these are the type of things where if you know how to do them, you're going to be able to code more effectively because you're not going to be sitting there like, how do I do this? And also they help you do things in modern ways, which is less typing. For example, for those of us that are old, remember what it was like when you needed to read a file. Well, you went to the internet or a book, and then you found the buffered reader thing, and then you found the null, and you put the parentheses in the wrong place. There are a lot of procedure to that. That's one line. And if you know how to do it in one line, you're going to be faster than the person who's still copying and pasting from the internet the way we did this 20 years ago. All right. So the first piece of code is not an idiom. It's how we used to do things, which was tree index of palm less than 0. This checks whether or not it's a palm tree. And it does work, but it makes you think. And anytime you see something with string indexes, you should think this is not how we write code anymore. This is how we used to write code. IntelliJ even tells you not to do that. There's a contains method, which is perfectly good. So I wrote if tree does not contain palm. That's a lot more readable. It's easier to remember, and it doesn't invite off by 1 errors to happen. Much better. And it was introduced in Java 1.4. So I'm sorry that your 1.2 friends application can't use it, but everyone else can. Also, their biggest problem is not the readability of the code. So I don't think they'll care. Then we have the same deal with white space. We used to write string.trim.length = 0, which isn't terrible, but it requires a lot more thought in reading it and more characters to type than actually necessary. There's a perfectly good is empty method you can use, so you avoid the length = 0 bit. And if you're on a newer version of Java, there's a strip. Strip is preferred over trim because it supports more expanded characters. If you're working with non-English characters, this is super good. And so you can see that was added later. And there's even better, there's a string is blank that was added in 11, so you don't have any of that ceremony. That's way easier to read. And it makes you faster because you don't have to use autocomplete twice in order to get it to work. Yay. There's a lot of discussion going on. I hope the internet people can hear me. Next one is string concatenation. For string concatenation, if you're old, you were learned that you use string buffer because strings were expensive and you didn't want to be concatenating them. And then we're like, okay, but string buffer is slow. We're not going to do that either. We're going to use string builder. Like, okay, you don't need to do that either. Plus now performs the same as string builder. Some IDEs will tell you that and some won't. IntelliJ actually tells you that you don't need string builder anymore. However, Sonar has rules that say, oh my God, you're concatenating string. So use whatever your team convention is, but be aware we're not doing the first one for performance anymore. We're now doing it to appease the gods of Java of 10 years ago. Okay, now we have whether 2 strings are equal. You can use the equal method for that, but you shouldn't. You should use content equal because it checks whether it's null, and then you don't have to do the whole if null thing before you're equal. Another idiom, saves you time, saves you bugs when the null shows up that nobody saw coming. If you get in the habit of always using content equals, you don't have that problem. Then we have how we used to write case insensitive equals. You picked your favorite of lowercase or uppercase. You made both strings that, and then you called equals, or you made a mistake and it always returned false and you got to hunt down why that was. Could be either. All right. There's equals ignore case. That's been available for super long time as well. Another idiom in order to write string code faster. Same deal for comparator. There's a compare to ignore case. No reason to call lowercase unless you actually want lowercase. Now, I know what you're thinking. We don't create CSVs using string concatenation. And you're right, please don't. OpenCSV and Apache libraries are very good for this. But I needed a realistic example that fit on the screen. So we're doing comma separated files here. But again, don't copy this and say Jeanne told you to write comma separated stuff in Java. This is a way of writing the comma separated thing in Java. It works. Not good, but it works. It can be written in one line. String has a join method, and you pass it your delimiter and your fields, and you're done. It's just as bad as the first example. It doesn't handle any of the special characters you need in Excel. But if you're not going to use a library because whatever, at least you can write the code in one line. And it's easier to read what's going on too. I can eyeball that second one and be like, yeah, that does what it says. Then I can tell them off for not using OpenCSV. Okay, now we have multiples. This is a loop that gets 10 of the same string. That can be done in one line as well. Since Java 11, but still useful. We can format strings, string, integer, float, or double, and new line. Tomorrow's gonna suck. I'm really sensitive to error stuff. I was lucky though. I was out of town last time, so it's gonna be my first experience with it. There's a formatted method that you can call directly on string that makes it a little shorter and faster, but that's not available till 15, so you have to be on 17 to use it, alas. Then we have text blocks. Those also come up in 17. If you're not on 17, you want to be really excited about text blocks for the future. These two pieces of code are exactly the same, except that one of them is significantly easier to read. Text blocks don't make you do so much escaping. You get new lines for free. You get single quote escapes for free. So you can really see what the format of what you're doing is. Super useful. I find it the most useful, ironically, in unit tests, because unit tests, I'm often using the golden master pattern where I want to say this is my expected output. When I can read that expected output, it goes so much better. And you know what we all did. I know I'm not writing code that looks like the thing on top because it's unreadable. So I'm going to put it in a file so that it's readable. Well, now I have the code to read the file and I have to go on a treasure hunt to see what it is. Much nicer to have it right before my assertion. String expected text block, string actual thing I'm calling, assert equal. The end. No problem getting things out of sync there. It's a very helpful feature when you get to Java 17. One thing to know about text blocks is that there's two types of white space. There's essential white space and incidental white space. The essential white space is the part of your string. Sorry, Barry, I'll be right back. This is your essential white space. It is part of the XML. You want to keep it. This is incidental, which is only there to make the reader of your code and the IDE happy. We can move this over in either direction, and it just increases the amount of incidental white space. It doesn't actually change your string. Okay, back to where the camera is. Also, there's no trailing new line in this example. If I wanted one, I would actually have to press enter after the set close session tag, and it would provide me one. So I have control of whether there's a new line at the end of the string or not. I chose not to because I wanted it to match my initial example, but either way is fine. And there's a bunch of other new APIs. They're fairly specialized in their use. I included index of for completeness. I wince when people use index of now. I don't think adding another index to it makes the code any clearer, but good to know it exists and use with caution. Now we're going to do a little review. I'm going to ask about what API you use for something, and y'all are going to tell me. So how do you check if a string is empty? What method should you use? Is blank. Yes, I'm trying to teach the new way here. Is empty works, but it requires you to call length. Is blank much better. It requires you to call trim. Is blank much better? Okay. How do you make a duplicate of your string? Repeat. I heard repeat. Very good. How do you merge multiple strings? Join. Good. How do you compare case sensitive strings? Yep. Compare ignore case and non-case sensitive. Yes. Equals ignore case. And that completes module 1. So now we're going to look at some code. In the lab version, people had a good while to write this code. You just get to read it. Way easier that way. I assume the font is big enough because it looks humongous to me. People in the back, good with font? All right. So the first thing people had to do was use is blank and string join in order to show they knew how to use those APIs. These copious comments are because I wrote a unit test that checks that you're using the right things. So I needed a start and end delimiter for each method. I gave this presentation at KCDC. So we have whether it contains KC, it finds it, and then it calls the new repeat method to get 3 of those. Nice and easy. Then we show we can use equals ignore case. We show we can use the new formatted directly on a string. And then I had them create tic-tac-toe board using a text block, which is kind of fun. It actually looks like a tic-tac-toe board, like you would expect it to. Then they call the formatted method and have the tedious exercise of creating the 9 values correctly. That is not interesting, but it takes a while. So anyone who was able to do the other questions fast had something to do. And then you had, if you had even more time, I showed how you would write it without the text block. So if you wanted to write this thing here without using text blocks because you're on older version of Java, it looks like this. Even using repeat to say how many there are, this is still a pain because I have to read this. All right, there's a line and then there's cells. How many cells? Okay, there's 3 cells. Then there's another line and there, right? And I have to envision all of it. With text blocks, it's a grid, right? You can tell really easily what it is. So text blocks are the future. Use text blocks for sale. Are there any questions on the string portion before we go on to regular expressions? The question is there a content equals ignore case? Not as of Java 20. I can't predict the future, maybe one day, but not right now. Any other questions on strings? All right. Now we go on to regular expressions, which is one of my favorite topics. Regular expressions or readable regular expressions are really powerful tools if you use them right and don't make them scary. This is not going to be how you write obscure regular expressions on one line. Those do not save anyone time. Do provide us with humor though. Okay, so first we have if we want to remove something. That's a really easy one. You call replace all. You say what you want to remove and you say what you want to replace it with. This replaces all of the numbers. It's a character class from 0 to 9. And you replace it with empty string. I also noticed 2 people taking notes. I should have said at the beginning, this entire presentation is on speakerdeck.com/Boyarsky. I don't remember if I uploaded this one in particular, but the one I did last week is on and it's the same thing. So I will try to remember to upload this one, but if not, it's there already. Okay, so note that we're calling replace all and not replace. Replace replaces just a string with a string. Replace all replaces all instances of your regular expression with a string. Okay. What are 2 ways you could remove blank spaces from this? So if we want to remove the blank spaces and not just the numbers, what's something we could do? Star S? Oh, yes. \S. Yes, you could do that. You could use a special character. Can someone else think of another way? Yes, adding a space after the inside the 0 to 9 character class would work. I'm going to add a third way. The third way is after you call text replace all to chain it and do replace space empty string to highlight that regular expressions are not always the best way of doing things. I think all 3 of those approaches are equally clear and equally viable though. But now we have removing something from the beginning. This time I'm calling replace first. Replace all works, but there's only going to be one beginning. So replace first is a little clearer as to what's going on. And I added a plus because now I wanted to replace all the digits from the beginning, not just the first digit. Okay, now I can do the same thing at the end. $ anchors to the end. So I'm using replace first again, because again, there's only going to be one end of the string. Dot means match any character. And the \\/ is to escape it and make it a real dot because I don't want to replace any character. I want to replace an actual dot. We all know what the second \/ is for. It's because it's Java, so you need to escape the first \\. Okay. You can also remove something from the middle. If we look at just the regular expression part, we can see that we're capturing characters without a comma, another comma, any characters except the comma, another comma, and capture characters without the comma. The reason this is written in plain English is to avoid this whole regular expressions are unreadable. I can't understand your regular expression. If you tell me you can't understand this line, we're having a talk that's not about regular expressions because there are no regular expressions anywhere on that line. The regular expressions are above it, and that's by design. It makes it easier to write the code because you're thinking about less at the same time. And it also makes it easier to troubleshoot the code. I'm calling my variable any characters except comma. If what I have in there isn't a comma, even the most junior intern is going to be like, your code is confusing. It says it's about a comma and I don't see a comma. And then we can discuss whether it's the variable name that's wrong or the lack of comma that's wrong. But once you reviewed those simple or regular expressions, all you have to do is put them together in the proper order and you have a regular expression that is readable and easy to understand. I use this technique heavily. I like it a lot. Then in the replace first, we have $1 and $2. Those are back references. Those are saying that the things in parentheses are going to show up again. So we're finding the thing at the first one and the last one, and we didn't choose the thing in the middle, so we don't need it anymore. However, there could be an off by 1 error here because we had 1 and 2, and who needs to remember what they are? So you can do better. But first, we're going to look at an ugly regular expression. I don't actually expect anyone to get this, but if you've tried to figure out what this does, it's got some parentheses and then it's ugly and no one's using that. But you could write the same thing, and that's the slide I showed before because I forgot again to fix this and only have 1. Sigh, I'm going to forget a third time because I can't write it down now. All right, so we've got our quick reference. Star is 0 or more. 1 is 1 or more. Question is 0 or 1. Dot is any. 3 X's, you can use squigglies to say how many you want. You can do a range. You can do not a range. You can do a digit, a white space, or a word. And this is pretty much the limit of useful regular expression syntax that makes things readable. There are a couple of other advanced things that are fair game to use. But then there are a lot of other ones that people will be like, well, what about \D? That means not digit. Like it does, but people don't remember that. Also, is that a lowercase s or a capital S? Allow me to get out my spectacles. So try not to use things that are going to confuse the people reading it. So we're going to try a quick little test as a group and think, not all the ways, just a few ways, that we can match at most, that we can match 1 or more X's. You can have 1 X in your RegEx or 2 X in your RegEx. You can't have more because I don't want someone saying you can write X question, X question, X question. No. So what's the simple way that we could say that we want 1 or more X's? X braces 2 would give us 2 X's. We're trying to get 1 or more X's. X plus is the simplest way, right? What's another way we could do it? Yeah, XX star, good. Let's try one more. X in brackets, all right. And there's a whole chord of them that you can use. I use that example to show that there's a simple way, X plus, and you should always use the simplest way that you can do something and not invite trouble. You can also split your string on a regex and get all the parts of it in an array. In this case, we're saying that it could be either space or comma separated. And if there's more than one of those in a row, we're going to treat them as one thing and get all the interesting things out of our string. We can say we want to match whether they're only digits. So true if it's only digits, false if it's not only digits. At least one digit, anything, a digit, anything else. Okay, then we have case sensitive. I could use a case sensitive operator, or I could just list them out. It says I'm going to have 3 X's of either case and replace them all. Or I could use the question I and say I want to treat this whole thing as case insensitive. And which one you use depends on your scenario, right? This is short. It's pretty clear that what I want. If I had to do that here, you would never be able to figure out what the thing did. It would be like bracket WW bracket bracket, where it would be like, stop that. So in this case insensitivity is helpful. We can do a multi-line replace. Question M treats it as multi-line. And then we can do question S for dot all, which treats the new line as any character. So you can use dot star and have it span new lines. Don't parse XML or HTML with RegEx either. It's like CSV. There are libraries for that. Then we have the pattern idiom. You create a readable regular expression, right? Nobody can say open tag is complicated. Then you create a pattern from that regular expression, a matcher from the pattern and the thing you want to match, and then you loop through it and get what you need. You can do the same thing with replacing. Here we're using append replacement, and then there's append tail. If you don't do append tail, the end of your regular expression disappears and you're sad and you look under the couch and hope you can find it. That's where my regular expressions are. All right, so how do we match a digit? Okay, it's just a clicker. How do we match a digit? \d. Everyone said /d. Your regexes aren't going to work. Okay, what method do we call if we want to remove a single match? Replace first. Good. What if we want to treat the dot as if it's any character? Question S. How do we match the same character 100 times? Yes, X curly brace 100. I was waiting to see if someone was going to tell me you type X 100 times and count them all. That would work. One time I did this presentation and somebody remembered from module 1 that you could call string.repeat. And they're like, you write x.repeat 100. It's like, that does work. But no. What method do we call if we want to loop through the matches? That one's fine. I went through that part too fast. And what do we do if we want to match a period? I heard backslash. Yes, backslash period. Again, these people with the slashes, your regexers are not going to do what you think they're going to do. All right, let's take a look at some code that people wrote when they were writing the lab for regular expressions. Yes. Oh, yes. The pattern is cached. Oh, sorry. What's with pattern and matcher? The pattern is cached. If you're going to use the same pattern multiple times, you're supposed to make it a static variable so that it can optimize the execution plan of it. Matcher is throwaway because it knows about your string. Good prompt. Okay, so then we had them write some regular expression stuff. Here we had them split on a space. They also sneakily introduced optional. This is the pattern we were talking about before. I did not cache it for readability, but you could. This is getting all of the digits going through, and for every digit, turning it into every set of digits, turning it into an actual number and returning that. Then we have the same thing, except we want underscores to be allowed because in Java, you can use underscores in your numbers. So it stands to reason that you could have to parse it. So the changes there were, first we added the underscore to the character class of what we were matching. And then we did a replace. Note that this is not the regex replace first or replace all. This is just a string replace because I don't have a regex here. I have a string. So I don't need the slower regular expression search. And I get rid of all of those and then turn it into a number because while my method takes underscores, integer.parseInt does not. And then we're showing how to remove the name in one line. So I'm doing multi-line. We have many lines here. Name, white space, dot, $, gives, and then replacing the whole thing with just the name. And that's what I've got. And if it doesn't match, it does nothing. So it's perfect. And then we do the same thing the long way with the pattern to get practice using append replacement and append tail. And then we have a tricky regular expression. The moral of the story is don't do this. But this does in fact remove the stars from the front and the back. We've got our front and back anchors. We've got our star and we've got the backslash because star means something. It's a meta character. And of course we have the second backslash because we have the first backslash and they like each other. Are there any questions on regular expressions? Okay, our next section is a little longer. And there's a few exercise blocks inside of it to make sure nobody's brain has time to fall asleep and you retain lots of information. All right. So suppose we want to create a set in one line and we're on old Java. The way we would do that is we would create a list on one line because that we're allowed to do. And then we would put it in a new set and we would have our set in one line. This works. It's got two problems. The first problem is that this is long and complicated. And the second problem is that our set is mutable. We don't really want our set to be mutable. And yes, I know there's collections methods you can call and stuff to make it not, but you could do this so much more simply. In Java 11, you can write set.of and list out all of your numbers. It's a var arg, so you can go on forever if you like, but after a point, your colleagues will be like, really, this is how we're doing this? Okay. And the set created by set.of is in fact immutable, which is probably what you wanted in the first guy to begin with. But nice. And I said 11 because I'm only considering LTS versions. Nobody's using 9. If you were using 9, you'd have upgraded by now. Okay, now we have a list. We used to use arrays as list. That was sort of immutable. You couldn't add or remove numbers to it, but you could change numbers inside of it. It was called an array backed array list. Not array back list, so not exactly what you want. There's list.of, it's immutable, and it's a handful less characters. How nice is that? Okay, then we've got our mutable list. This one I want it to be mutable, so I wrapped it in an array list. It's pretty much the same thing, but you use list.of, so it's a little faster. Okay, we can make a mutable copy. We can make an immutable copy. List has a method for immutable copies now, list.copyOf. That one's super convenient. Can create a synchronized list if we want to wrap our list and make it thread safe. Can make it unmodifiable, which really shouldn't because you would have used list.of, but maybe it's not starting out as numbers. Maybe it's starting out as a real list. Okay, then we have our character create a map. I create maps all the time when I'm writing JUnit tests. And it's my least favorite part of the test because it's distracting from what I'm actually trying to accomplish. I just want to say these are the values, but I have all the ceremony. You can use map.of just like you use list.of or set.of. And if you only have 1 or 2 pairs in your list, this is awesome, right? It's fast to type. And if I've only got 4 parameters, I'm not losing track of what key and what the value are. After I get past 4 parameters, I start to be like, there's too many things here. I can't follow it. And that's when I'll switch to map entry so that I can actually group them together. But in unit test, I often have 1 or 2 pairs in my map. So this is the common case, and then I don't need that ceremony. Also, the unit test isn't going to production. It doesn't have to be the most hardened thing on earth. It has to be clear. Okay, now we have sorting. You can call sort directly on list instead of on collections. Pretty cool. Saves a couple characters. It's also more intuitive. Same deal, but you can sort backwards. You can pass your own comparator. You use a method reference in order to say what you want to sort by. You can remove stuff from the list. We've been able to do that for a long time. But you can also remove if from a list. I really like remove if. I use that one a lot in unit tests as well. And all this emphasis on unit test is these are where your little operations are, right? The code has more big meaty stuff like streams, which we'll see shortly. My test is like, I want an element. I want to see if it matches an element. I want to assert on the element, and here's my 3 rows. Not that much to it. So I like remove if for removing everything except the thing I want and then asserting what's left. Shorter than a stream, easier to write, clearer what's going on. I don't do that in real code because it's not the fastest of things, but we've already established that my test has 3 things in it. I think the performance will be just fine. So for remove if, you use a lambda or a method reference and you say what you want to remove. So I want to remove all the matches here that have a certain first name. You can use list.contains to see if there's an element in the list. You can also find a match. If you're using equals, of course, you could have done this in one stroke with contains. But if not, you've got logic you care about. In my case, I want the first name. So I can call any match and pass it the thing that I care about, and it will tell me if there are any. So this is saying, does my list contain any targets that have the first name of name? Nice. Okay, I can double my string. Contrived example, but it does show that replace all exists. And then we have the Venn diagram operations. Those are fun. We all remember Venn diagrams, right? It's like why cats are like vacuum cleaners, and then we see what's in the middle and what they have in common. They're self-cleaning. That's a good one. So union puts the things from both collections into the same one. That is add all, right? You start with one collection, you add everything from the other collection. It's a set, so it deals with the duplicates for you, and you're done. Intersection is the one in the middle. The cat is self-cleaning and the vacuum is self-cleaning. For that, we use retain all. We put all of the elements in one set. We say what we want to retain all of the elements from the other set, and the ones that are left are the ones that we have in common. Retain all, surprisingly, is a method that a lot of people don't know exists. And I think it's because it's not useful every day, but when it's useful, it's super useful. And I will see colleagues that will sit there and write a loop for something that retain all does. And when I ask why they didn't use retain all, I get this blank stare. And they go, because I didn't want to pull in a third-party library. Like, I know, I'm not asking you to pull in a third-party library. Promise. And then we'll rewrite the code and they'll be like, my code is one line now. Yeah. And then distinct, things that are in one and not the other. My cat has a tail. My vacuum cleaner does not have a tail. You put it in one set, you remove all of them. What's left is your distinct. Should get a tail for my vacuum cleaner. I think that'd be fun. Give the Roomba a tail. Maybe it can clean itself. Roomba likes getting stuck on things. Now we have defaulting values. You have a map and you can call map.get. And we all know the ceremony there. Map.get key equal null, right? That's what we do. We handle the nulls. There are a number of methods on map that don't make you handle the nulls. One of them is getter default. Get me the value. If there isn't one, tell me what it is. And guess what? This is also useful in unit test because in unit test, you're doing an assertion. So if I expect it to be 42, map getter default my key, comma 0. Assert 42 equal that thing, comma, I'm expecting it to be 42 because it's meaningful to me. 0 is not equal 42. It fails. I don't have to write that extra logic. You can add to the map if it's not present by using contains key input, or you could just call put if absent and have Java do it for you. And then there's a variety of other useful map methods. Do keep in mind that entry set, key set, and values are backed. If you change them, you change the original map. If you don't want to do that, please make a copy before you make your changes. Okay, yes. Oh, remove key comma value is conditional. Only remove this entry if the key and the value match, right? So remove key 42. If it's 43, it leaves it alone. I forget about that one because I don't use it that much. It's probably useful in some domain, but it's not the one that I'm in. But it does exist, and it seemed like one of those methods that is good to spread awareness of because I bet someone in this room is thinking that method is useful. It's not me, but I could see it being useful to somebody. Okay. Now we have for each. For each is not for changing things. This is not meant to be a for loop. It's good for looping through and printing out, and it replaces some very short streams. But if you find yourself writing stuff with side effects in a for each or a stream, you're doing it wrong. Okay, and this is what I was talking about before. You can get it from different places. So for map, you can use entry set, or you can loop through the map directly and get the keys and values. Okay, so we have our first review of this section. Remember, there's more than one. How do you create an immutable copy of something? Yep, copy of. Good. How do you remove all the values less than 5? Remove if. Yes, I'm glad someone remembered remove if. My job here is done. How do you update the value in a map if the current value is 10? Oh, update. Yes. Replace. Sorry. I thought it said remove. How do you return 0 if the value isn't found? Get or default. And how do you find the intersection of 2 collections? Retain all. Yay. People are listening. This is exciting. You got pizza and brain food. All right. Now we have some code here that finds the maximum value of a list, I think. I say I think because every time I look at this, I have to read it and be like, yeah, it really does that. And that's a problem. Luckily, you don't need to do it that way. You can use a stream. We have our stream. We call map to int, which makes it a number so that you can do numerical operations on it. And then you call max and you're done. It's shorter and it doesn't require that head scratching of that does return the maximum, right? It does. And it's got my anti-pattern in it because we're subtracting 1 from the size. When you're doing that stuff with numbers that doesn't involve actual math, it's always, is there really, is that a better way of doing that? You can join a string. We learned already you could use string join, or if you want to use, if you don't have a string and you have something else, you can use a collector and join that way. In our case, we have objects and not strings, so there we are. Okay, you can get the first element. I do a lot of stuff with builds, so I'm often looking for the first or last after some condition. Take while is available in newer versions of Java. That's keep giving me elements until we find one that doesn't match. So this gives me all of the elements that are failing, and when it sees the first success, it stops. Useful to me. This is 9 and 16 because take while was introduced in 9 and toList was introduced in 16. ToList is syntactic sugar for collectors.toList, but the take while is super useful and available sooner. Okay, we can get an element that's drop while. That's the opposite. Keep skipping all those failing builds and let me know when you find one that passes and give me the first one. So I can write logic on the thing that passed and is representative of the state of your project and not the last one that happened to happen. Yes. You can, yes, you can use, the question was, can you use filter? You can use filter instead of drop while, and then you would use first afterwards. Drop while is more efficient and clearer in some cases. Filter is more efficient and clearer in some cases. Note that you cannot use filter if you have an infinite stream, and you can use drop while because drop while will stop when it finds one that doesn't match. Filter will sit around filtering them until you give up. So equivalent a lot of the time, not always. Barry. Yes. Oh, internet question. Oh, it's speakerdeck.com/Boyarsky. .com/Boyarsky. And Barry's typing that into the chat for anyone who doesn't know how to spell my last name. It's also under the YouTube video that you're all looking at. Okay, good question from an internet person. Also good to know there is an internet person. Now we have some operations on strings and characters. On string, you can call .lines, which breaks up your string into lines and turns it into a stream for you, and then you can do whatever you want with a stream. There's also on a string, there's .chars, which does the same thing, but for characters. So it breaks it up your characters and you can do whatever you want with those. There's also a bunch of useful terminal operations. You can use count, you can use collect, all match, any match, none match, find any, min, max, for each, to array, to list, and many, many more. There are also a whole pile of interesting intermediate operations. All right, now we're gonna see if people know stuff. How can you return whether 5 of 5 values are 7? Yes, all match. And it was really hard to phrase that question without using the word all. How about returning whether 1 or more values are 7? Yeah, any match, not a trick. These are important, so I want to make sure. There are a good number of answers to this one, but what's a method that can make your stream smaller? Yeah, filter's good, limit, skip, there are lots of them. How can you change the order of your stream elements? Sort, good. How can you loop through your stream elements? For each. How can you ignore the first 2 elements? Skip. Someone whispered skip. Be more confident it is skip. And how can you ignore any elements that are, it's the same thing. How can you ignore any, forget, I'll reword that one later. So these same bugs I had the first time I gave it, and I lost the paper I wrote them on, so I didn't get to fix them. And this time I don't have a paper, so hopefully I'll actually remember to fix them this time. All right, now we can do infinite streams. You can generate an infinite list of stars. You then need a method that can make things smaller and deals with infinite. So this turns it into 10 stars. You can use iterate to do the same thing. Or in newer versions of Java, you can use iterate and have your condition all in one line. These all do the same thing. I find the generate one to be clearer because it is saying how many there are and isn't making me do something that looks like a loop, but that's personal preference. And then there's flat map. Flat map turns a list of streams into a single one. It's like flattened and groovy, except less clear. Creating a map, you pass to map, you pass your key function, your value function, turns it into a thing. And there's a third optional parameter where you say what happens if there's a conflict. If you know there's not going to be a conflict, this is fine. If you think there might be a conflict, you need that function, because what Java will do if there's a conflict is say there's a conflict, woe behold me, I'll throw an exception by. And that is absolutely not the behavior that you want when there's a conflict. So you have to specify what happens, and it can be as simple as I don't care, just pick one and don't fail, right? That is a far more preferable behavior to have in your code than I give up, I've crashed your program for you. You can group by key. This creates a map where the key is, the function string length is the key and the value is all the matches. You can also partition, which is the same thing. It creates a map, except the key is true or false and the values are the same thing, a list of all the matches. You can also do more complicated stuff. So you don't have to have the value be all of the matches. You can have it be count of all the matches or any other function that you want. You can combine things with math. Yay. Okay, reviewing. There's a whole bunch of methods that we talked about here. They're all really good. Okay, practice again. How can you create an infinite stream of a times table? No, because it's a times table and that has sequences in it. So you can't use generate. What can you use? Iterate. Yes, you can use iterate. If I wanted an infinite stream of X's, I could use generate. But my times table is going to be 1 times 1 and 2 times 2 and 3 times 3. So I need to have order matter, and that's why I need iterate. Okay, how can I create a map that always has 2 keys? Yep, partition by. Good. Creating a map with a custom key value. That one's 2 map. And what, there are a few choices for this, but what's something you could call that returns an optional representing the stream? Find first. Yeah, find first returns an optional. Now we'll look at the code I made people write, and then we will do our final module. Okay. So module 3, the first thing I did is I had them make this class immutable. So we're creating a copy of the array list for the presenters so that it is a copy. And on get presenters, we're doing list.copy of, so that's a copy as well. It'll get better in the next lab. We're showing you can use getter default to return a null and optional of nullable. So you've got your optional empty, and in only 2 lines, we got an optional out of our map. We showed how to loop through using remove if instead of a stream to get all the presenters. And then we showed the same thing with the stream, and you can see that they're roughly the same length. So on some level, this is a personal preference type thing. We showed how you can get the presenters, when the ones with multiple presenters, and then sort it because we want to learn how to sort stuff. Then we did the same thing as a stream. This time we called sorted. Then we found the largest room number with an odd number. So we mapped to get the room number. We did a filter to get the odd numbers, and then we got the one that was the largest. So we called max and natural order. Then we did the same thing for lower than. And then we got all the titles with a certain prefix and showed we could join them. So it's pretty straightforward. Streams are streams. Now we've got our last section, file IO and other useful APIs, aka Jeanne's favorite APIs. Although I like file IO a lot too. So we're starting out with records. Raise your hand if you've seen a record. Okay, not a lot. Raise your hand if you're at this presentation because you've seen a record right now. If you're at this presentation because you've seen a record, it's on the screen. You've all seen a record. Barry's looking at me like I'm nuts. I'm trying to wake people up. If everyone has to raise their hand, they have to think. Literal. I'm not tired. I'm fine. All right, this is a class. It's got 2 instance variables, title and num pages. It's got a constructor, it's got getters, and it would have some other stuff except it didn't fit on the slide. This whole thing can be written in 1 line. Public record book and your instance variables. It uses a getter that doesn't have the word get in it. So we've got title instead of get title, but it generated everything else for me. So we've got an immutable class, we've got accessors, we've got a constructor, we've got equals, hash code, and toString. all in that one line of code. Very good idiom to keep in mind. In fact, before we had Java 17 available to us, I started not including get in my getter names so they would be forward compatible with records. And then once we upgraded to 17, I used phone calls to replace them with records. A lot of fun. So what'd you do today? I wrote negative 100 lines of code and attended a phone call. Okay, but it does help because if you look at this record and ask, well, what does the equal method do? Well, it tells you that whether title and num pages are equal, right? There's nothing else you need to think about. If I have the whole long equal method, even if I generated it using my IDE, now I have to look at it and see if someone tampered with it or wrote it by hand and introduced some sort of a subtle bug. That's going to take me a lot longer than reading the one line. Okay, now we're creating a path. Paths are useful because you're going to do file IO in a moment, and you have to create a path in order to do your file IO. So you call paths.get, and that gives you a path which represents your file. You can have it all in one shot, or you can separate it out. Or you can even use a legacy file if you have one available to you. Then we can call methods. You can get the absolute path, super useful for debugging, right? Java says it can't find the file. Where's the file? Who knows? Call to absolute path, and you will know too. And then you can look at your file system and see that there is no file there. And then you and Java can reconcile who is right about the location of the file. Spoiler, it's the code. And then there's file and path separators. You can read a file into a string in one line. There's a couple ways of doing it. The older way is you call files.readAllBytes and wrap it in a string. The newer way is you call files.readString. Which one you use depends on what version of Java you're on. But both of them work, and both of them are far better than, hold on, I have to Google that buffered reader thing. And I've been programming for 21 years. I still can't do it from memory. Now, granted, I haven't tried in many years, but I wasn't able to do it from memory when I did it often. So I doubt that I would be able to if I continued. You can also read the file into a list. Files.readAllLines gives you a list that you can pass around and do whatever it is. Or you can use a stream and call files.lines. Note that that is in a try-catch block. Files.lines does not close your file for you. We all know that closing files is important. So putting it in the try-catch allows that behavior to be preserved. You can write a file too. Works the same way. You can use bytes or a string or a list. You can append to the file. Super useful. You just add a pen to it. You can walk the tree if you want to go through an entire directory structure and find matches. Sometimes you have to have an unchecked exception because inside of a stream, unchecked exceptions, the stream doesn't know what to do with them. However, everything in file IO throws a checked exception, an IO exception. One of the easy ways of dealing with that is to write your own wrapper method or wrapper class that does nothing but convert it from a string, an IO exception to an unchecked IO exception. I wrote a whole class of these so that everybody on my team just shoves unchecked in front of the word files, does organize imports, and moves on with their life. But even the one method somewhere in your project is helpful. Okay, you can delete a file, delete the file if it exists. All right, review. How do you read a file into a single string? Read string, very good. How do you write a list into a file? Write, good. How do you get rid of a file? Delete, by file. How do you list all the files in a directory? Walk, there's also list directory, which I didn't cover because it's less interesting, but if you know that one, it's also right. How do you add something to a file? Append. And how do you process a file as a stream of strings? Right. Now we've got our math. Math has lots of methods. They all do what they sound on the front cover there. There's absolute value. Sorry. Oh, yeah, sure. The question was, should peak not be used in production? Correct. Peak is meant for debugging. It's good for printing out what is in your stream in the middle of the stream. It can have side effects, and who wants their production code printing out stuff every time you go through a stream? So yes, it should not be used in production. Good question. Are there more internet questions? Okay, I'll do another round of questions at the end. Okay, so we did this already. Okay, so the math methods do what they sound like. This is just, I went to a presentation and Jeanne said there were math methods. I'm doing something with math. Let me pull up the Java doc. So absolute value, max, min, power, random. You can also use random to get doubles, which is good. You can get them to get numbers between whatever you want. It's common to add 1, because I don't know about you. I often want a random number from 1 to 10, not from 0 to 9. So adding 1 is common in order to get the numbers that you actually want. You can get an infinite stream of randoms. That's fun. So give me an unlimited number of integers and I will do what I want with them. You can make that finite by passing in how many integers you want, more useful than the infinite stream. You can get a more random number than random gives you with UUID. Then there's dates. Local date is the new Java 7 way of getting dates. And I use new in quotes because I keep seeing people write stuff with the old date. Stop that. This isn't new. Local date is immutable and it's clear. So you can call now to get that moment in time. You can give it a year, month, and a day. And you'll note that is a month in plain English. It happens to be 1 index. So it's also, if you use numbers, you don't have to use 0. But it's way better to use the word because 1, it's easier to read. And 2, the older programmers are going to see 2 and know that it means February and not wonder if you meant February or March. You do math, add days, subtract weeks, add years, whatever you want. Very helpful and easy to read. You can get certain days. This is President's Day of 2020. I'm going to skip this because we just did it. And before we do win a book, I'm going to show the last code and do internet questions and in-person questions. And then we will do the win a book or IntelliJ license. Okay, so the code in the lab, we rewrote workshop. It's now a record and therefore 1 line. There is some overlaid stuff because it's got some custom methods. So like toCSV is not in a record, so we had to write that by hand. Then we wrote some stuff with file.write and showed how you convert a checked exception to an unchecked exception. Less familiar with this lab because usually people leave. We have remove if going on again and file write. We've got the same thing with the room number. We've got some more stuff there. We've got more stuff with writing. Here it shows how you put all the odd numbers in and then you put all the even numbers after that, which is kind of fun. We can delete files. We can get more stuff out of the stream. We can walk the stream. And we've got some stuff with dates and we can show we do date math. This conference was 2 days, so we added 2 days. And that's pretty much the interesting part on that. We've got random numbers. Okay, we're going to do a round of questions. Who has a question? Okay, the question was, how do you deal with static code analyzers and new idioms? Some of these idioms are standard, so you could just import the Sonar rules for it. But a lot of static analysis tools have the ability to write your own, like PMD lets you write XPath rules. So you can write logic for that. But I find that code review is a more effective way of doing it than idioms, than static analysis rather. And the reason for that is people learn idioms at different speeds. When you're pair programming with someone and you're doing code review, you're pointing out one thing. It's like, hey, in that scenario, here's how you could do it better. When Java 8 was new to my team, we had a running joke that Jeanne did stream consulting. So someone would come by with a piece of code that they wrote and go, how do you streamify this? And we would sit and we would rewrite their code together using streams. And that helped them because it was a piece of code they had. It was real. It wasn't a toy example. And because they were coming to me, they were open in that moment of learning how to do it. Right. There were other times where they were super busy and it's like, I don't care how to do this with streams. I want to get it done. And there were also times where people would come to me with code they wrote a week ago of, I wanted to know how to do this with streams, but I had a deadline then. So I didn't want to know then. I want to know now. Can we rewrite it? Sure. Right. So, it depends on your mileage may vary, but I think spending the effort teaching people is more valuable than teaching your static analyzer to say that this piece of code, which isn't wrong, is bad. Do it this other way. Other questions? Yes. Okay, the question is, what can you do as an alternative to peak? Well, for debugging, you don't need an alternative to peak because once your stream does what you need, you no longer need the contents in the middle. If you really do for some reason, I would argue that you have 2 streams and not 1 stream. So you should do the logic up to the point where you care about, store it in a collection, do whatever with that collection. Maybe you email it to yourself or write it to a file or whatever, and then do the second part. A stream pipeline is a stream pipeline. It's suspect to need things in the middle. And more importantly, it's functionally incorrect because the stream is welcome to optimize itself in any way it likes. So the output you get in peak may not be what you want. And putting that in your production application is super dangerous, right? If I think I'm counting things and the answer is 5 and I only see 3, I'm like, oh, well, this is wrong, right? But if I'm filtering things and I don't see the later ones, that's because Java knew it didn't need them for a later stream operation. So if I really needed that interim data, I would need to put in a full-fledged data source. This is a little bit like quantum where the results are only guaranteed at the end. So I would not use peak in the middle of a stream for anything short of trying to understand why it isn't working the way I expect it to be. And even then I try not to use it. I try to have a smaller stream, get that working, and then start adding to it until I figure out what I did wrong. Nice question. Other questions? The first one is start as small as possible, right? A stream only needs 2 components, a source and a terminal operation. You're not messing up stream and collectors to list, right? I think everybody can agree that's simple. Then add something to it, add a map, add a filter. So you can get most of the way without needing to debug because you're building it up slowly and correctly in ways you understand. The other one is if you're uncomfortable with the logic, write lots of unit tests because once you know something's working, you ensure it stays working. Finally, your IDE is your best friend. IntelliJ does an awesome job of telling you what type each step is in the stream. So a lot of the time when you're writing a stream and you have a long thing with map, flat map, you forget what it is. And then it's like, why does my code not compile? Looks like it compiles. And then you look at IntelliJ and it says you have a list of objects. I was like, what? Oh, I didn't call that. So that information alone helps before you even get to running it. Other questions? Do any of the computer people have questions? I'm imagining stick figures in Barry's computer watching this presentation. Okay. If you work at Goldman Sachs and are doing day trading, ignore this advice. Oh, sorry. The question was performance streams versus for loops. Sorry, Barry. I was good when the audience did it, and then I forgot when you did it. If you work at Goldman and are doing day trading, ignore this advice. They have a whole new level of performance. For the rest of us, streams are usually the same or faster than for each. And in reality, the performance difference is negligible. The reason streams sometimes perform better is that optimization thing I was talking about. They don't have to do all of the work that a for loop does. The other thing is streams are open to parallelization. Parallel stream only performs faster when either you have a lot of data or you have an operation that's slow. But changing from stream to parallel stream is not a lot of work. Changing your for loop to a parallel stream is a ton of work. The times that I use parallel stream the most are when I'm working with REST APIs, because most of that time is sitting around waiting for the REST API to get back to you. So those parallelize super well. In fact, my teammate wrote one of those last week and he asked me, he's like, is this okay? And it's like, yeah, that's great. And he wanted to make sure it wasn't a side effect, but it wasn't. It was a data operation because it was a get. So that was fine. But it's really cool because he started with stream. He saw it was slow. He made it parallel stream. He consulted with an expert and then we were done. If he had been in a loop, we would have had a whole discussion about what to do and trade-offs. And Are there any other internet questions, Barry? Okay, the stick figures in the computer are happy. Any more questions in the room? Yes. Yes. Okay. So the question is performance. You get it working and then you need to performance test it. First of all, make sure the piece of code you're performance testing is your actual bottleneck, right? We all know how important that is to tune the wrong thing. After that, if it's a web application, I would use an actual performance testing tool to make sure I know where the bottleneck is. If it's a tight algorithm, I would either use a unit test or performance test suite, hammer it, run it. I don't deal with performance tests where the granularity of my answer matters, right? I was trying to get this thing from an hour to 3 minutes. It doesn't matter if it's 2 minutes or 3 minutes. Everybody is happy that it's faster than an hour. So for that, the unit test is enough. and we're back to the whole, if you're day trading, ignore that advice, because then you very much care whether it's 1 millisecond or 2 milliseconds. But if you're performance testing on a web app or a business process that's just really long, people are just generally happy, then it's faster. Also, keep in mind the beginning of performance testing is the low hanging fruit, right? You're going to get it from an hour to 15 minutes pretty fast. Getting it from 15 minutes to 2 is where it becomes a lot of work. Any more closing questions before we do prizes? Mm-hmm. Okay, the question was, with the string builder is unnecessary for concatenation and loops, how do you find out about that? I found out about it from a teammate, so I am living proof of the whole you hear about it from other people. And I've told many people, so I tried to make it a virus and tell people. The way I keep up with stuff is reading blogs and reading tech Twitter and such, but I hadn't come across that particular fact. And unfortunately, there are still old Sonar rules that tell you don't do that. So when he told me it was faster, I didn't believe him. And then when we went on the internet and looked together, and of course he was right. Yes. Yeah, IntelliJ tells you where you can replace string builder with string. That's how the guy who told me found out. I learned about this before I used IntelliJ regularly. But yeah. What version did string concatenation become just as fast as string builder? There was, I don't know what it was, but it was a long time ago. It was definitely before Java 8. So everybody in this room except the 1.2 friend is fine. The thing is, I don't know if it's 6 or 7 or 8, but it's long enough ago that none of us need to worry about when it was. I'm sure the answer is on the internet, but it's definitely not later than 8. Yeah. I found out about it many years ago, and I was slow to find out about it. But I was using 8 at the time I found out about it, so I'm confident that 8 is fine. But like, I can't tell you if 7 or 6 are fine. I also don't know if it was like, a switch where they made that faster, or just slowly got better over time on certain CPU, and then it was fine. Okay. Thank you all for coming to this meeting. Our next meeting is next month. Does anyone remember the topic? Okay, it might be Amazon, it might be a surprise. Follow us on Twitter or Mastodon or our mailing list to find out. Thank you, internet people. Have a good day.